Welcome to the PrepNet, presented every Sunday at 6 p.m. Eastern Time on Talk2Me's Channel 14. Come join us to discuss everything about prepping and hear what others have done. All about communications. Communications Modes, Part 3. Last week, we finished the radio communication voice modes of single sideband and digital voice. Now, we will move into digital text communication modes. These modes mostly fall under amateur radio, so this discussion might encourage you to get your ham license. Digital text modes allow operators to send written messages over the radio using a computer connected to the transceiver. Instead of speaking into a microphone, the operator types a message on a keyboard. The computer converts that text into a series of audio tones, which are transmitted by the radio. At the receiving station, another computer decodes those tones back into readable text. Why use these text modes when I can just talk into the radio? These modes are especially useful when signals are weak, noisy, or fading, making voice communication difficult or impossible to understand. Some of the digital modes are error correcting to ensure your message is correctly received at the other end in all but the most extreme conditions. Another advantage is that most computer programs used for digital modes will automatically keep a complete log of what you transmitted and what was received, making it easier to review conversations and maintain records. The other advantage of these modes is that they are great for sending instructions or lists of needs, as the receiving party can print them out for reference and not have to rely on memory. Now, to some of the many digital modes available. Radio teletype, or RTTY, is one of the earliest digital communication modes used in radio. RTTY, usually referred to as RTTY, works by sending text using two alternating tones, often called mark and space. Here is an example of what RTTY sounds like over the airwaves. These tones represent binary data, similar to early computer systems, and takes up 270 to 370 Hz. RTTY is relatively simple and robust, and it is still used today, especially in contests and special events, and usually transmits between 60 and 100 words per minute. The strengths of RTTY. RTTY is easy to set up and widely supported by many radios and software programs. It allows real-time keyboard-to-keyboard communication. Limitations of RTTY. RTTY is not very efficient in terms of bandwidth compared to newer digital modes. It also does not perform as well in very weak signal conditions. PSK31 is a very popular digital mode designed for efficient, low-power communication. The name PSK31 comes from phase shift keying at a rate of 31.25 baud. Instead of switching between tones like RTTY, PSK31 changes the phase of a single audio tone to encode data. Here is a PSK31 signal. PSK31 will transmit data between 50 and 70 words per minute, depending on the PSK31 mode used. This is slower than RTTY, but PSK31 can receive and decode weaker signals than RTTY can. Strengths of PSK31. PSK31 uses very little bandwidth, typically around 31 Hz. It works well with low power, making it ideal for portable and QRP operation. When I run PSK31, my power is usually set to around 20 watts. QRP refers to operating with very low transmitter power, typically 5 watts or less, to achieve efficient communication with minimal power. It allows smooth, real-time keyboard conversations. Limitations of PSK31. PSK31 can be sensitive to tuning errors and interference. It is not as robust as some newer modes in very poor signal conditions. Olivia is a digital mode specifically designed for weak signal and noisy conditions. It uses multiple tones and forward error correction to ensure that messages can still be decoded even when parts of the signal are lost. Here is an Olivia 16-1000 signal. It is much slower than PSK31 at 15 to 60 words per minute, but the error correction makes up for the slower data transfer. There are more than 40 options of Olivia to pick from. Strengths of Olivia. Olivia performs extremely well in weak or fading signal conditions. It can successfully decode messages even when signals are difficult or impossible to hear by ear. Limitations of Olivia. Olivia typically uses more bandwidth, from 250 to 1000 Hz, than very narrow modes like PSK31. It also transmits data more slowly due to the extra error correction. The popular digital program FLDigi supports RTTY, PSK31, Olivia, and 100 more digital modes. It can also transfer files using FLAMP and forms and messages using FLMessage. This screen shows a waterfall display 3.5 kHz wide, the same space a single sideband transmission takes up. Note how many digital signals are in the same space one single sideband transmission would take. Digital signals can pack more conversations into a small amount of radio spectrum and be decoded under conditions where voice communication would not be possible. JS8Call is a modern digital communication mode and program based on the FT8 waveform, but designed for actual messaging rather than just signal reports. It allows operators to send short structured messages, acknowledgements, and even relay messages through other stations. Unlike many other digital modes, JS8Call is designed to support more organized and intentional communication. Stations can call specific operators, send directed messages, and even leave messages to be picked up later. JS8Call also includes features that allow stations to automatically respond to certain commands, such as signal reports or location requests, which makes it useful for building simple communication networks. Strengths of JS8Call. JS8Call works very well in weak signal conditions. It supports semi-automated messaging and network-style communication between stations. It can store and forward messages, allowing communication even when stations are not available at the same time. It allows operators to build informal networks in which messages can be relayed across multiple stations, extending the communication range beyond a single direct contact. Limitations of JS8Call. JS8Call is slower than voice communication and some other digital modes. Because it uses structured transmissions, conversations are less free-flowing and more sequential, and it requires computer control and familiarity with the software. Next week, we'll continue with more information on digital modes, such as continuous wave, commonly called CW, practical application scenarios, and meshtastic. If you have any questions about what we have discussed here or anything about prepping, send your question to prepnetch14@gmail.com and enter question in the subject line.